Hello, everyone. Today, I'd like to talk to you about the Google PageSpeed Insights, or time to interactive, and how to get amazing scores with a new technology we're working on called Qwik. First, a little introduction. I'm a CTO at Builder.io, where we're working on making sure that anybody can create amazing websites fast for their e-commerce websites. I'm known for Angular, AngularJS, and Karma. And previously to that, I was working on Clean Code Talks. A little bit about Builder. So Builder is a headless visual CMS systems. CMS means it's a content management system, which allows marketing department, for example, to change things on the e-commerce website, such as the sales or the image on the front, or rearrange the way the landing pages look like. Headless means that it's running on your infrastructure rather than ours, so you own all of the benefits of content management and so on, and components. And the headless, the visual part means that it's a full drag and drop editor. It's kind of unique in the industry to have both headless and visual, and I think this is the unique part that Builder.io offers. The thing we were trying to do is we're currently focusing on e-commerce, but in the long term, we really want to focus on any kind of web application development. And this is the kind of the talk we want to talk about is how do we get there? So let's talk about our goal. And our goal is to make the fastest possible time to interactive. Now, there's a lot of different ways you can measure speed of your website. And I think just about any framework you choose will probably deliver to you just good enough performance. But time to interactive is something that the industry struggles with. And because the industry is struggling with this, Google is producing this thing called Google PageSpeed, and that is a metric that shows you how long does it take for the user to be interact with your website. And this information is actually being fed into the search engine optimization rank. And so now companies have a lot of incentive to improve the time to interactive score. And finally, everybody knows that time to interactivity actually equals money. If you have a website that is quicker to load, faster to show to user the content, the more money, the more of a conversion factor you'll have, and therefore the more money you will make. Now, if you look at the industry, one thing you're going to notice is that if you feed it through the Google PageSpeed score, and especially if you feed it on mobile, you'll discover that most of the websites are ranked red. And if it would be just one few websites, a couple of websites here and there that would be red, you could say like, well, that the company is not focusing on this particular thing. But the fact that it's across the industry kind of points to a systemic problem. It points to the problem that we are looking at the problem in the wrong way, and our tools we're using are just not good enough for the job. And what's interesting to notice is that even companies such as Amazon, who clearly understand that time to interactive matters, and they clearly spend huge amounts of time and effort on making the time to interactive as good as possible because it will directly impact their bottom line, even such companies are struggling to get the time to interactive in what Google would consider a green area. And so one of the things we would like to rethink is how can we get websites going that would consistently give you 100 out of 100 on Google PageSpeed rank. These are the fastest possible websites you can have. And the way to really think about it is that we all agree that the fastest possible way to get a site up is through HTML. And so instead of having JavaScript first kind of sites, could we have HTML first kind of sites without sacrificing any of the interactivity and any of the applicationness that everybody has come to expect out of websites? And so this is the kind of the focus of Qwik, is how do we build websites that can do this? And goal of Builder is to introduce Qwik for its customers and do it in a way that is open source so that anybody can benefit from this technology. Now, the thing I kind of touched upon is that the current set of generation of frameworks really don't help with this particular problem. Current generation of frameworks really focus on performance as it pertains to application already running, but there's very little that the frameworks do to help with time to interactive. As a matter of fact, like you could think of it as if we took the desktop model of building applications and we just brought it to the web. And this desktop first model of thinking about the problem isn't really paying great dividends for us. And as a result, all of the existing frameworks, doesn't matter which one you choose, will not have good time to interactive, as you can see by the huge number of websites that are struggling to get good TTI scores. So let's talk about the problem to kind of get started. Well, the way current generation frameworks work is that everybody agrees that we have to do server-side rendering, and so everybody pretty much does that. So we server-side render, that gives us HTML. We send the HTML to the client, and in the client, we have to do Bootstrap, right? And the goal is to get the application interactive. And to kind of really demonstrate why this is a problem, I think it's easier to kind of go backwards. So what we want is we want interactive website. Well, what does that mean? That means we have HTML, CSS, right, down under the client, but none of that stuff is interactive until click listeners, or rather DOM listeners, are attached to the DOM. So in order for the application or for the framework to actually know where the click listeners are, it has to execute the templates, right? So the render function is the only function that can possibly extract the locations of click listeners. And so in order for the framework to set up the listeners and make your page interactive, it has to get hold of the render function. And so downloading the render function means that the application has to be downloaded. And not only does it have to be downloaded, it also has to be executed. But in order to execute a template, one of the things you need is you need a state of the application, right? So it's not sufficient to just download the template. It's also you have to download the state management. And once you have the state and the render function, you can execute it, and you will be able to, the framework will be able to know where the listeners are, will be able to extract the listeners. And these listeners are really closures. And these closures oftentimes close over other pieces of code, such as in the case of a add to shopping cart button, it will close over the shopping cart code, which means that the shopping cart code has to be present and downloaded before you even click on the add to shopping cart button, right? And so the result of this is that there's a huge amount of code that has to be downloaded ahead of time to enable all this stuff, right? So the way the Bootstrap actually works is that you have HTML, you come here, you call a Bootstrap method, which then has to download a whole bunch of code that the server just executed. And so it has to download it again on the client. Also, it has to recompute the state. Now, you can kind of serialize the state from the server and get it to the client. And then it has to take the state and merge it with the render function so that it can rehydrate the DOM and figure out where the listeners are. And at this point, your application is interactive. And if you think about it, this big arrow here is kind of the issue. And the more complicated your application gets, the more complicated this arrow becomes. It is relatively straightforward to get good green score on page SEO for a small application, but as the application becomes more and more complicated, this particular arrow gets bigger, and this is the kind of the issue that we have with time to interactivity. And the way I like to think about this top portion right here is that this is replayable application architecture, right? The client has to replay all of the operations that the server just did, and it needs to replay it so that the client can get to the same state as the server was, so that when the rehydration of the DOM happens, which is a fancy word for just attaching the DOM listeners, we end up with the same UI as it was when it was rendered on a server. So now let's look at how Qwik does it. Qwik's goal is to basically delay as much of the code as possible for as long as possible. And so again, we start with server-side rendering. We execute Bootstrap, but what's unique about this Bootstrap is that it is tiny. It is less than a kilobyte and less than 1 millisecond. And what's more important about it, it is constant. No matter how complicated your application becomes, no matter how complex and how rich your UI becomes, your Qwik startup code is always going to be less than a kilobyte and less than a millisecond. Now, the next important part here is that because of the architecture of Qwik, you get to bypass the render and update state and go directly into interactive state. One of the things that Qwik does is it serializes all of the information it can into the DOM. And because of this, the HTML that comes from a server already knows where all the listeners are. And therefore, there is no need to replay any of the renders or any of the templates in order to figure out where the listeners are. So we would like to talk about Qwik being resumable, right? It resumes where the server left off rather than replaying all of the work that the server did. And because it's resumable, the amount of code that needs to be downloaded and executed is very, very tiny. And this is what gives you amazing time to interactive applications. Now, the thing is, existing technologies simply do not have this particular way of thinking, and they force you into this paradigm of replayability. And this is the thing that is causing all the troubles. So let's have a look what it looks like. So here's our to-do app. One of the things I can do is I can click on a performance, and I can ask the tooling to kind of collect all of the information. And one of the things we're going to notice is that the request came in. This is where HTML was sent. And all of the code, as you can see, has executed in 0.6 milliseconds. So it's a tiny amount of code. The other thing we can look at is we can look at the network and refresh this. And what we're going to notice is that no JavaScript actually gets downloaded at the beginning. The reason for that is because the 1 kilobyte JavaScript that needs to get downloaded and executed is so tiny that it's actually cheaper to inline it into the index HTML rather than having a separate request and pay the cost of the overhead of the request. And so this is where the application becomes fully interactive. Now, kind of the most important thing about it is, let's look at this input button right here. You will notice that it serializes what we call on key up, right? So it says, like, if there is a key up event, then go ahead and download this header add to do so that the application can continue. And because the information about where the listeners are directly inside of the HTML, the little tiny bootstrap can set up a global listener for all key up events. And whenever a key up event occurs, it can use the bubbling property of the DOM to capture the event at the root, figure out where the on-key up property is, download the associated piece of code, and then execute this. So if I go to the network tab, and if you can look at the code over here, the moment I hit a key, additional code gets downloaded and executed. And as I interact with the application, more and more code gets executed and downloaded. And this is kind of the key to Qwik, right? If you look over here, the way existing technologies work is that all of the code is downloaded upfront. Yes, there's lazy loading strategies, but those are mainly on route level. It's not really possible to do it on initial render. And because everything's upfront, it's expensive. The way Qwik works is that there are many places where lazy loading can occur, and the lazy loading is a property of the framework rather than something that the developer has to think about and set up their code and kind of hook into. So let's talk about our philosophy. So the philosophy here is actually pretty straightforward, which is that nothing is faster than doing nothing, right? You can endlessly debate about which framework is faster at rendering, but if you don't have to render, you will simply win this battle because there's nothing to do, right? Server has already did all the work. It built up all the HTML and sent it to the client. There is literally nothing to do at the client, which means it's the fastest possible thing to do. The other interesting part of this is that all of the Qwik's application state is actually in the DOM. And because it's in the DOM, it's fully serializable, right? DOM already has a serialized version of itself, which is HTML, and HTML has attributes. And so this allows us to take the running application on a server, and at any point, we can ask it to serialize into HTML and ship it to the client, and it can just continue. It can resume on the client where it left off. This resumability property is actually the key property of Qwik, which makes it fast. Because if you're not resumable, you are back to the replayability world, and that's what will force you to download huge amounts of code. So one of the things we want to do is we want to aim for 100% of lazy loaded code to be executed. The way you can think about this is that in the existing frameworks, because you're forcing to download all the code ahead of time, huge portions of that code will not be executed, which means that you will be forced to download the code for, let's say, a shopping cart. But unless the user actually clicks on an add item to a shopping cart, that shopping cart code is actually dead code, dead weight that you had to download and not execute it. So Qwik actually aims for 100% of the code to be lazy loaded and executed. And this we can show you here. If we go to coverage, let's look at JavaScript right here. One of the things you will notice is that at the beginning, we have our initial piece of code. Currently shows 2 kilobytes because it is not minified. But you can see that about half of it doesn't get executed. So that's pretty high. But at the moment we interact with it, that falls down to 5%. The other thing you'll notice is that as we're interacting with the code and the chunks get downloaded, almost all of the code gets executed. So as you can see, we have 20%, 18%, 5%, 4%, and 0% unexecuted code. The idea is to keep this as low as possible. And as you interact with the application more and more, you'll see that the percentage of the unused bytes is actually kept very, very low. And it's one of the key properties of why Qwik can achieve such fast time to interactive. So getting a good time to interactive score is just not easy. And it's not easy because you can look at the empirical evidence in the industry and you will notice that everybody is kind of suffering with this problem. And you can look at the current generation of technologies, whether it's Angular, React, Vue, Svelte, and they all have this replayability property, which means that they force you to bring too much code at the very, very early application startup. And that initial code is really what time to interactive is, right? You want to make the application interactive as fast as possible and then get out of the way. And then in the background, you can start downloading additional code and get ready for the user interaction. And this is the property that existing technologies do not have. And I think existing frameworks, really, we've been locked in this battle about which is the fastest framework, and we continuously, have metrics and performance numbers that compare them. But the industry really has gotten to the point where all of the existing frameworks are fast enough. The reason why your application is slow is not because your framework is not fast enough. It's because your time to interactive is what's keeping you from improving your conversion ratios. So let's talk about a couple of problems or existing way about thinking about building the applications that are actually at the root of this particular problem. So the first thing is what I call death by closure. And death by closure really deals with the fact that, we use closures everywhere. And I'm not saying closures are not good. They're super useful, super they're the thing that we turn to when we build just about anything. But they do have a cost. And I don't mean cost of allocation of runtime. I mean the cost of download at compile time. Because closures close over code that they will execute once you invoke the closure, that means that code has to be eagerly loaded, right? So in the case of a click listeners for a button, when you have a button that, for example, adds an item to the shopping cart, the instructions of how exactly does one add an item into the shopping cart, those are inside the closure and they're closed over. And whether or not you will click on that button, that because the closure is in the template, that means when you download the template, you are downloading the closure for that behavior, and you're also downloading all of the code associated with this behavior. And because existing frameworks expect these closures to be executed synchronously, there is really no good place to place your asynchronous loading for your lazy loaded code. And so I think the big mental shift one should have is that these frameworks should actually be actively involved in lazy loading. And you can notice that all existing frameworks really don't have a fundamental primitive for lazy loading. They all have patterns and they all have suggestions or best practices on how to do lazy loading, but none of them are actually fundamental primitive of the framework. The other way to think about it is that we have reactive systems such as Svelte, and the reactive systems require you to set up pipes, right? Saying that if this piece of code here changes or this piece of data changes, then I have to update this template right here. And this kind of setup requires you to essentially create a closure for the listener. And so whether you have reactive systems or just plain listeners, you really are paying the cost of closures that are slowing you down. Qwik, of course, we use closures in Qwik as well. But one of the things we are cognizant of is that these closures have cost. And so as a result, we have fundamental not design patterns, but fundamental properties of the framework, which take lazy loading into account and have mechanisms for doing it, for delaying the execution of the code, and for updating the UI in this way. So let's look at a typical website, such as Amazon. So this website might look static to most people, and it kind of is, but at the same time, it's very rich. We have a complicated set of menus at the top, which need to work. We, of course, have our shopping cart here. The item we're looking at, we can click on buttons, we can hover over it, etc. We can choose different versions of the same item. And of course, we can choose the quantity and add it to the shopping cart. And so in the existing framework, right, in order for this page to become interactive, we have to download all of the templates that were used to build this. And because some of these templates can be quite complicated, such as the menu system or the product details and viewing of the product, we are forced to pay for all of it, regardless of whether or not you click on it. And because of click listeners, right, this button right here will have a closure, and that closure will contain information on how to update this thing over here. And of course, it will also download the template associated with it. And so at the very, very beginning, your application has to download all of these templates and all of these codes so that it can run through rehydration. And the big difference with Qwik is that we can delay all of that work until the user actually does the interaction. So we kind of already talked about it, but the key point to understand is that the current generation of frameworks are all in the replayable mental space. And this mental space is kind of a natural extension of, if you were to be building applications on a desktop, that's kind of how you think about it, right? You don't think about like, oh, I have to download some code or things that are lazy bound, etc. You just kind of say like, well, all of this stuff is kind of available to me. And as an outgrowth, all of our existing frameworks also have the same kind of a mental model where everything is available and the frameworks don't provide primitives for lazy loading or breaking up the application into individual parts. The way to think about it is that typically all of the existing frameworks really have a initial bootstrap path, which kind of hinders the lazy loading, right? So when you want to bring the application back to life, you have to call the framework's bootstrap. Now, every framework has its unique thing, but the key to understand is that the bootstrap is really same no matter how the user interacts with the application. And this is very in stark contrast to something like Qwik, which is resumable. There is no bootstrap, right? When you come to the client, there is no main method or the entry point to your application. Instead, your application has been already run in a server, and all you have to do is resume it. And so in a sense, every single listener that exists on a page is a bootstrap, right? When I click a button to add to the shopping cart, then that's the bootstrap that gets just that portion of the application bootstrap. Whereas if I click on a menu, I will get a different port of the application bootstrap. And because there's lots of different ways, there's as many ways to bootstrap the application as there are ways of interacting with the page. There is no centralized prototypical way of bootstrapping your application. Instead, this is all split across the interactions. And because it's split across the interaction, what you can end up having is a idealized perfect bootstrap for each interaction that the user can take. So let's look at this particular page again. The big difference with Qwik would be that the server obviously serves up the HTML. HTML is shown. Qwik sets up a global listener for all the events, and that is it. We are done. Now, when the user goes in and tries to interact, for example, with the menu and clicks on the menu, it is at that point that Qwik will go and bootstrap just the menu component and nothing else. On the other hand, if the user goes and clicks on the size of the hammer, again, the Qwik will bootstrap just that component and nothing else. If the user clicks on the add button, the Qwik will bootstrap the add button, and then the add button processing will update internal state, which will invalidate the shopping cart component. And so the Qwik will bootstrap the shopping component and update that as well. But again, nothing else on the page gets downloaded or updated or executed. And by focusing on the key areas of the page that are being updated and executed, we are significantly cutting down on the amount of code that has to be present on the client and has to execute. And because we're significantly cutting down on it, the initial execution of the code is significantly smaller. And because it's significantly smaller, the fact that we're doing it on just-in-time kind of download and execution actually is not a problem. The other thing we can do is obviously we can keep track of what is the user most likely to click on, and we can cause preloading of all this code in the background without paying any of the cost to time to interactive. So obviously, if the user comes to the page often, the caches are warmed up, less code has to be downloaded, and so the interactivity will be even faster. But we can start warming up the caches because we know what a prototypical user behavior is, and therefore we can start pushing code in the correct order to the client. Now, one of the things to kind of think about is how existing frameworks keep track of state of the application. And the reason why this is important is because what we would like to get is out of order component rehydration. When I say out of order, I mean typically components are in a tree hierarchy, and we have parents, we have children to our components. And so imagine you have a middle component shown over here. And let's say that middle component has a button that you interact with. And so you update the state of the application. And that state of the application needs to be reflected inside of the child right here. Ideally, what you would like to do is bootstrap just the child, because you understand that only the child is referencing the state, and only the child has to be re-rendered and nothing else. Existing systems have troubles in two ways. First, let's say for the child has to be re-rendered. No existing system allows you to render the child, but not render its leaves as well. Most systems will automatically force you to download, will have a static import from the child to the leaf. And this static import means that the moment you are executing the child, you're automatically executing all of its children as well. And even if you can somehow prevent the execution of the child, you still did not prevent the download of the child. And so the child forces you to download the leaf. So that's the most obvious way that this thing breaks down. But there's also a reverse relationship to the parent. And that is, if the middle goes and updates the state, and if the framework doesn't know where the state is reflected, well, in that case, the only sensible thing to do is to re-render the whole page and start at the parent and go from to the children. And so all non-reactive systems have this property that is Angular, Svelte, and Vue, which is that if you update its state, really the only thing that the framework can tell you is that something has changed, and as a result, we need to render from the root. And that means that any change in state will cause a flow re-render. What it means in practice is that any change in state will cause you to download the full application and execute it, right? Qwik aims to break this apart and know that if I update the state, then only a child gets executed. So these systems are called reactive systems. An example of that would be Svelte. However, for Svelte to set up the reactive pipeline, it has to set up these closure listeners that we talked about earlier, which means that the cost of setting up the notification system about, this state updates this child, forces you to download and execute all of the templates. So while Svelte at the runtime can intelligently update which parts of the UI need to be updated, it does so at the cost of downloading and executing all the templates ahead of time to figure out what the graph is. So one of the important things that the Qwik can do is it can know how this reactive system, what the relationships of the components are, and this information is downloaded and serialized into the DOM so that when the applications are resumed, the information can be used to figure out, oh, you've only updated the state, and this state is only reflected in this particular component, and therefore only this component needs to be executed. To give this example is, if you click at the button right here for adding to the cart, you update some state that is associated with that cart, and Qwik can then determine, without executing any code, just by looking at the state of the DOM, that this state, the shopping cart state, is actually used in this UI element right over here. And then therefore it can invalidate that element, download its template, and execute the template to re-render that particular code. It knows that the state isn't used in any of these components, and therefore it knows that none of these components need to be downloaded, executed, or rehydrated. And this is where the savings come in. By focusing on only the code that needs to be done, we can get these fine-grained, what I call out-of-order component rehydrations. So in most systems, rendering is not fine-grained. And this is kind of the key thing to Qwik. That is, we want to make sure that rendering is fully fine-grained, so we can only update an individual component. So let's look how this actually works. So here we have our to-do app again. We can look at the elements. One of the things we can notice is that each component has a decl template, which is a declaration for a template. And it says, like, if you decide that this particular component is something that needs to be updated, here is the URL where you can go and download it. Now, in addition to that, if you look at the section, you will notice that it has a lot of state associated with it. And these state is associated in the form of JSON serializable strings. And this is the state really of the application, so that when the client wakes up, it can continue without it. Now, if we go in here and we create a new item, and we hit enter, you will notice that 3 will need to be updated, as well as this list over here. So what Qwik needed to do is to figure out which of the components needed to be updated. And the way Qwik did this is it can execute a query selector. And the query selector can ask for, hey, which components are actually interested in a particular state. So each state has a specific ID, and we can ask, hey, who's interested in it? Oops, it's plural to-dos. And notice that the query selector can answer that question. This information is fully stored in the DOM, and this is what makes it serializable and resumable. If we were not storing this information in a DOM, the only way for the framework to know this would be to download all the templates, execute all the templates, and figure out what the relationship between things are. By storing this information in the DOM, the Qwik framework can resume where the server left off, and it can reason about the state of the application without having a full access to everything. And this is how Qwik knows that these two components are the ones that need to be updated whenever a new item gets added. And when we click on it, you will see that the footer specifies, where does the template get needs to be downloaded. So if you look at the network tab, and let's refresh. When I click new item, right, and I hit enter, why is not? Sorry, when I hit new item, here we go. It downloads a set of code, and then when I hit enter, it will download the main template and the footer template, because it knows that those two templates are the ones that needed to be re-rendered. What you will not find in here would be the template for the application or any other template that isn't needed at that particular point in time. So one of the things I think we got wrong as the industry is that browsers are not desktop applications. And yet we tend to build our applications as if we are in a desktop world. And browsers have these things called UI, which is declarative through HTML, right? They're highly dynamic. They have a very rich, lazy loading system, and they have all kinds of late binding mechanisms that exist. Whereas the current generation frameworks really have imperative UIs. We really favor static imports. We have fully synchronous rendering, which prevents lazy loading of renderable components on a fly. And we really try hard to abstract and hide the DOM away. And I think we are basically operating at the wrong level. We're not meeting the browser eye to eye. And I think this has kind of been here before. When at first the industry started building web applications, one of the things we kept saying, like, oh, JavaScript is problematic. If we only had a better language, we would have an easier time to build web applications. And there was a point in the industry where we were continuously trying to reinvent the kind of language we are trying to use to build web applications. And in the end, if you think about it, we basically learned to love JavaScript. Yes, there is TypeScript, but the key difference is that TypeScript doesn't try to replace JavaScript. It just augments it. Whereas all of the other languages that came before really fundamentally tried to replace JavaScript, and none of that actually worked. So I think we're in the same state where we are trying hard to pretend the DOM doesn't exist and pretend the browser doesn't exist. And we're trying to abstract the browser and the DOM away instead of just saying, like, let's learn to love and take advantage of the benefits that these two things offer. And this is what Qwik comes into play. Qwik really focuses on trying to take advantage of the browser and what the browser offers in a way that meets the browser where it is. So let's talk about the conclusion here. So the point of this talk was that really nothing is faster than doing nothing. And so what the Qwik allows you to do is to delay as much as possible for as long as possible. The other thing we really want to focus on is to have super fine-grained lazy loading. I would say that the current lazy loading support in existing frameworks is extremely coarse-grained. Here, it's coarse-grained, for example, because you cannot split up the components from its listeners. When you have a component, the component listeners are automatically in there, which means if all you have to do is to re-render the component, you have to download not only the template, but also all of its listeners and all of the behavior to with it. So even on a low enough level, such as separating the component out from its listeners, existing frameworks just don't have the mechanism to do so. And the other thing is that Qwik really tries to be DOM-centric, DOM serializable, and stateless. Stateless not in the sense that the state of the application doesn't exist, but rather that the framework doesn't actually keep state internally. Rather, all of the state of the application is reflected in the DOM, and DOM becomes the source of the truth. And because DOM is the source of the truth, the application can be serialized at any point, shipped somewhere else, and it can resume where it left off. And so this is kind of our big focus on talking about resumable applications versus replayable applications. So Qwik is an open source project. The primary focus of Qwik is to help builder make its e-commerce websites amazingly fast, but it is done in fully open source manners, and we would like it to benefit the outside of the industry as well. And so we're open sourcing it for the rest of us to use. You can go check it out on StackBlitz. Thank you for the StackBlitz folks for figuring out how to integrate Node.js into a browser. Because Qwik is so heavily focused on server-side rendering, the Node.js is a kind of a requirement to demo how Qwik works. Anyways, there's a StackBlitz. You can go and check it out as well. I would like to thank you all for listening and taking the trip with us here, and hopefully this was informative.
Hey, it's Joe Eames with ng-conf. If you like that video, be sure to click subscribe either here or here, somewhere over here. And if you're looking for something more, here's another video for you to watch here or there or somewhere.